What's up, hackers? Welcome to TTI Live. My name is Taggart, and today we're going to change it up a little bit because, well, one, I wanted to try an experiment, and two, we have a pretty special topic today that I like to do every once in a while. It's been about 9 months since I did it last, and that is a clinic on Docker. So if you've heard about Docker, if you're curious about it, if you don't know anything about it, but you want to know more, this is where you need to be. This stream is going to be, and the saved video, of course, is going to be everything that you need to get started from a basic understanding of the Linux command line all the way to being able to run multiple Docker containers in an environment of your choosing and understand what you're doing when you spin up those containers. So strap in. We have a lot to do for today's stream. Now, if you like the Week in Cyber News segment and you miss it, let me know in the Discord, because I'm playing around with formats and trying to see what makes sense where, and there may be other places that the news segment makes more sense than right at the top of Saturday streams. So if you're interested in it, you feel like it's something missing, definitely give me that feedback. All right, let's begin. So today we're going to spin up Docker servers. We're going to need at least two, if you want to play along, we're going to need at least two virtual machines. They don't need to be beefy, but they do need to exist, and they need to exist in the same network so that they can talk to each other. You can do this wherever you like. You can do this in VirtualBox if you want. You could do this in VMware. You could do this in AWS, Azure, or you could do it in your Proxmox node if you're cool like me. That's what we're going to do. So we'll spin up two virtual machines, and we'll do it manually just so we don't muddy the waters with anything else like Terraform or anything like that. We're going to focus on Docker for today. So I'm going to head over to my Proxmox node here, and I am going to just take my SecLab Ubuntu Server 2204. This is my Ubuntu 2204 template, just a server, and I'm going to make a couple of clones here. They're not serious. They're just two cores, 2 gigs of RAM. They're really not that big. They think of them like Raspberry Pis. That's basically all they need to be. And so I'm going to take one, I'm going to clone it. And the first one I'm going to call Docker Manager. There's a reason for this. We'll clone that one. And then we'll do it again. And we'll call this one Docker Worker. Not Doc Worker. It's not a stevedore. Now, we're going to set both of these up at the same time, but for the majority of today's stream, we're only going to be working with the manager. But I want to show you how to set both of them up at the same time, just for ease of use. So let's start both of these up and make sure that they have, you know, different IP addresses. And let's see. They're on infrastructure. That's fine. Yeah, they can be on that network. No problems there. Start that up. I'm waiting to see IP addresses. So this is just preliminary lab setup. We haven't done anything Dockery yet. And you could be doing this in, again, any hypervisor virtual environment that you like. If you want to set up virtual machines in Azure, you can do that. They can be tiny. They really don't need to be massive. The B series would be fine in Azure. I'm not as familiar with AWS scaling, but again, 2 cores, 2 gigs of RAM, really all you're going to need for this. Okay, 192.168.99.116, and dang it. So this is a bug that I learned exists in Ubuntu, that when you spin up clones of a virtual machine, they will get the same IP address. There is a fix. I just need to implement it, but that's okay. So we will deal with that. We'll deal with that by making the worker get a different IP address. Yeah. I think we might have to just reboot the machine. So the issue is that this Etsy machine ID is what is used to generate a unique, essentially to identify the machine as a unique device. And if they all have the same machine ID, they're going to get the same IP address. It's a pretty dumb bug. So you can either just blow away the machine ID or find another fix for it. But hopefully when we restart this thing, it'll have a new IP address. Or we broke it entirely. Well, we'll wait for the worker to come back up and we'll focus on the manager for now, because that's where most of our work needs to be. So let's go ahead and connect to it. And I'm going to make this easy on my host, my jump box here, by first editing my hosts file. And go ahead and add, we'll call it 99.116. That was close. We'll call it just Docker Manager, so I'm not confusing it with any of my SecLab stuff. Okay, now that I have that host name created, I can SSH SecLab at Docker Manager. Looks good. Yes, I have multiple fingerprints, that's fine. And we're in. Now, this is just going to be some housekeeping really quickly, because this is, I find it easy to change up the host name when I'm working with these things to keep them straight so I don't accidentally SSH into the wrong server. So this is something you might want to consider doing. First thing we'll do is we'll sudo vim etsy hostname and change this to Docker Manager. And we'll do the same thing in the Etsy hosts file. We're just going to change that to Docker Manager like so. And then last but not least, we run sudo hostname Docker Manager. We exit and we reconnect over SSH. And now it's the Docker Manager. That is how you change host names in Linux. Let's see if our worker is up now. Yes. And we have an IP address of what? Hilarious. So we just broke it by removing the machine ID. Well, that's okay. We'll leave well enough alone on the worker for now. Because I want to get started with Docker. Okay, so just on Docker Manager then, let's install Docker. This is everything that you need to install Docker. So the documentation, this is going to be Ubuntu 22.04. You can modify it for whatever distribution that you're using. And I should say, yes, we're focusing on Linux. Why is that? Because the containers that we're going to be running are going to largely be Linux based. It is not impossible to run Docker on Windows or Mac OS, but it's a little bit funky. And generally speaking, in production, your container runtime is going to be running on a Linux host. So we're going to focus on that for today. I think what I want to do is I want to get Docker installed so we have the lab set up like up front, and then we'll talk about what Docker is and how it works. So we just kind of want to get the nitty-gritty out of the way, and then we'll dive into some concepts. So to get Docker installed on your server, we're going to follow these instructions here. And for a new install, you can safely ignore the sudo apt-get remove. I really wish they would remove the apt-get. It's not that anymore. It's just apt, but whatever. Because these have not yet been installed. So we're going to install this following these instructions. And we also don't need to worry about the apt update or install CA certificates curl, GNU PG, LSB release. Those are there. Those are there. So we're going to start with the sudo make dir etc apt keyrings. What we're doing is we're creating a place to store Docker's GPG key, which our package manager is going to use to authenticate the validity of the packages, right? This is a signing key. So we're going to first make this directory, and then we're going to run this curl command, and we'll explain what this curl command is doing. Let me zoom this in so it's a little bit easier for everybody to see. So we're going to curl, follow the redirects, and then we're going to get the GPG key, which is, interestingly, in base64. We're going to de-armor it to turn it into a binary blob, and then put it in our new folder, etc apt keyrings, that we just made, docker.gpg. So we're just storing the key. Okay. Now, if you want to, you can cat out the docker.gpg. It's going to be garbage because it's a binary blob. It's not printable. If you want to see what the GPG key looks like, you can just visit this URL and see it in its base64 armored format. Okay, now that we have the GPG key, we're going to add a source to Docker's package manager so that we can actually download Docker stuff. So let's take a look at what we're doing here. We're echoing something to a new file, etc apt sources.list.d. This is a folder that already exists in your file system. And we're creating a new file called docker.list. This is going to be the list of repositories used by Docker. What are we adding to it? We're adding a Debian repository. The architecture is going to be based on whatever we run from this command, dpackage print architecture. It's going to be AMD64, but that's fine. This part's super important, and it's why we did the first two commands. Signed by etc apt keyrings docker.gpg. This tells apt, our package manager, what key to use to verify the packages that are coming down. And then this is our source. This is the URL, and then we're using LSB release -cs for the code name. That's going to be jammy or kinetic or focal or whatever. In this case, it's jammy. And then stable for the stable branch. And we're sending all of that to this file, and we're using T so that not only do we see it output to our screen, but we're also going to put it into that file. Okay. Or we would see it output if we didn't do dev null. Okay. We now have a new source for our package updates. So if we run sudo apt update, you can see that we're now accessing download.docker.com to get some of our updates for our server. At this point, once the updates finish, take your time. There we go. Once the updates finish, we can then run this long update command. I'm sorry, this long install command. What is the host OS I'm using? That's a great question, Ahmed. I am running KDE Neon. And so pretty much stock, and I've customized the terminal a little bit with some Tmux wizardry, and I'm using the Terminator terminal emulator. Okay, so we're going to install this thing. Again, what I'd like you to get in the habit of doing, this is just for me and hopefully for your edification, I don't want you to copy this whole command. I want you to copy the package names, because I want you to get in the habit of not using apt-get. It's actually deprecated. I don't know why all these commands still use it. Sudo apt install, and then you can use -y to auto confirm, and then paste in those package names. We'll break down what each one of these is in just a moment, but let's run them. Okay, off it goes. So as this is installing, Docker CE is the community edition of Docker. The CLI is, of course, the command line interface tool. Containerd is our container runtime, and I will explain what that means shortly. And then Docker build X plugin, and then the Docker Compose plugin. This is new. If you've done Docker in the past, this part is new, where Docker Compose used to be an optional install later as just like a rando Python script. But now Docker Compose is in fact a built-in command to the Docker CLI. And this is how you install it rather than that after that DLC, basically. Whoop. Nope, didn't want to do that. Okay. So we have Docker installed, and Docker is going to set up a systemd service for us. We can confirm that it's running with sudo systemctl status docker.service. And sure enough, it's running. And if you really want to make sure that it works, you can do sudo docker image ls. And then you'll see this empty list of repositories, tags, image IDs created in size. Okay. What's the difference between the two? The two between apt and apt-get? They're the same package manager, but the command line interface has shifted to restructure around apt rather than apt-get. Could not understand Docker Compose. Don't worry. Sahil, we're going to talk more about Docker Compose later, but it's essentially a way of managing multiple containers at the same time. It's an orchestration tool. Okay, before we go any further, for ease of use, we're going to do one thing that I don't recommend doing in production, but is very handy when we're doing setups like this, which is we're going to add our current user to the Docker group. If you cat etc group, you'll see that the last entry is Docker. And in fact, yeah, if we do lsal var run, yeah, there we go. If we look at la var run docker, you'll see that there's this docker.sock. And this is the socket that the container runtime is using. And you'll notice that it is owned by root, but also has a group of Docker. And this means, note also it has the setuid bit. This means that anybody who's in the Docker group has the ability to run these Docker commands and interact with the container runtime. So we're going to do sudo gpassword-a seclab, or whatever your user is, Docker. And that adds the user seclab to the group Docker. And then we're going to s equals socket. Oh, thank you. Sorry, I was thinking about the... Good call. I was thinking about the binary. Okay, if you log out and log back in, now you can run Docker commands without sudo. And I don't recommend doing that in production, but when we're doing practice like this, it's just nice to not always have that sudo command. So Heil, don't try to compare Kubernetes to Docker Compose right now. Leave that alone. They are not the same thing. Okay. I want to quickly check on our worker to see if I can make a new one with a different ID. Or a different IP address, because I do want to have our worker up and running. while this is spinning up, let's talk a little bit about Docker concepts. So what do we use Docker for? Docker is a way of deploying applications in isolated environments that are easily redeployable, scalable, predictable, and I think really importantly, isolated. This doesn't automatically make them secure, but it does limit the exposure of the application from a security standpoint. But I want to also clarify that security is not the primary objective of Docker containers. The primary objective is predictable and reproducible deployment of application code. Now you might think, okay, but that sounds a whole lot like a virtual machine, right? We can spin up VMs with apps running on them and spin them down. What's the difference? The difference is bulk and architecture. This diagram does a pretty good job, I think, explaining the difference between a virtual machine and a container situation. So when we have a virtual machine, obviously we have the bare metal, and then we have the hypervisor that's running on top of it, right? A type 1 hypervisor in the case of Hyper-V or VMware, Proxmox, Xen, KVM. Or you have a type 2 hypervisor that is software governed like VirtualBox or even VMware Workstation. Those are type 2 hypervisors. But in either case, when those hypervisors create virtual machines, they are virtualizing hardware, but also importantly, they are virtualizing the entirety of the guest OS, as well as any of the libraries and binaries that an application requires to run. So every time we make a new VM for a specific application, all of this is coming with the dinner. On the other hand, with a container runtime, what containers do is we put in the container only that which the application needs to run that is unique to the application. So there are going to be some libraries, some binaries, configuration files, and then also the container maintains a running config of how it's supposed to operate. But then it shares a lot of the operating system kernel with other containers and with the host. And this interaction is mediated by something called a container engine or the container runtime. That's what Containerd does for us in the case of Docker. There are other container runtimes that exist. You may have heard of Podman or LXC, and those do the same job as Docker. They do them slightly differently, but their whole intention is to negotiate the interaction between containers and what they have and what they need from the host kernel. Can we use the same Docker machine which we created here in Ubuntu in Windows OS? We'll talk about images, so stay tuned for that. They're not machines, though. I want to be very, very clear about that. Docker does not make virtual machines. They make what are called Docker images, and they run containers, which we'll see in just a moment. Okay, let's run our first container, and we'll kind of go from there. In order to run our first container, we're going to do Docker container run. Now, you may have seen other examples do Docker run. And while that is still technically correct, it is an older form of the CLI syntax, and I don't want you to get in the habit of using it. It is more correct to use Docker container run. And as a matter of fact, it'll become useful to add that subcommand because that'll keep your commands kind of ordered between you working with containers, working with images. There are some similarities. So Docker container run, and let's just do hello world. Now, I want to pause here because this concept is very core. Docker containers are based on Docker images. Images are a snapshot of a file system with pieces that the application needs, this part right here, and a configuration about how it's supposed to run. A container is a running layer on top of that base image for anything that's happening at runtime. Docker images and containers are made of layers of changes. We'll see that more shortly. And so a Docker container, a running container, is just that last layer of changes that is active on the system. And that's what we interact with. Now, what that means for us is this container that we want to run, Docker container run hello world. The hello world is the image we're running the container off of. It needs the hello world image. But I don't have it. So the first thing that's going to happen is Docker's going to notice I don't have the hello world image and go to try to find it from the default the default image registry. Image registries are places on the internet or in a local network that you can pull container images from. Our default for Docker is hub.docker.com. Now you can pull Docker images from this registry without signing up for an account. But if you have an account, you can also push your images to the Docker hub and then use them on other machines. And you can also pay like $7 a month for a paid account. You get private repositories, things like that. But for now, let's just run this container and see what happens. So you can see it says unable to find the hello world image, and notice it has this latest tag. It pulls it, it completes the pull, and then it runs whatever is set to run inside of that container. Now let's see what happened to Docker images on our system after we did so. Docker image ls. Now you can see I have an image. The repository is hello world. The tag is latest. And that's because I didn't specify any other tags. It defaulted to latest. It has an image ID, and it was created 17 months ago. Luckily, it's very small. But there are other images that are going to be much larger. So let's grab some right now, just to give an idea. Let's do a Docker image pull Alpine for Alpine Linux. And again, we'll just use the latest tag. Alpine is great, especially for Docker containers, because it's very, very, very small. Notice that Alpine is only 7 megabytes. That's how much is contained in there. And it's essentially everything that is necessary for an isolated Alpine Linux environment. By contrast, let's pull the Ubuntu image. This is going to take a little bit longer. So while that's pulling, I'm going to go check on our... Oh, just kidding. I guess it didn't. But you can see it's much smaller than it used to be. But you can see that it's 77 megabytes. It's 10 times as large as the Alpine build. So I just want you to be aware that the image that you're using does have size considerations. There's one more that I'd like you to pull, which is the Nginx container. Sorry, the Nginx image. See, it's really important to keep those terms straight. Containers are running instances of images. Images are base snapshots. Nginx is a little bit sizable too. Yeah, you can see Nginx is the largest of the four with 142 megs. Okay. Now we just saw that we ran the hello world image and created a container. But we actually haven't seen containers run really other than the output of that. What happens when they run? So we did Docker image ls. Let's look at Docker container ls. There's nothing currently running because the hello world container that we spun up ran and exited. Let's do ls-a to list all containers both running and stopped. You can see there that we have a stopped container, or an exited container, I should say. It has a special ID. It tells us what the image was that it was based on, and when it exited. It also has a human readable name, in this case, Jovial Gould. We can specify names for containers when they're running as well. Let's try running one of our others. Let's try running Alpine. We'll do Docker container run Alpine. Just like that. Nothing seems to have happened. Why is that? Let's do a Docker container ls just to see. Okay, nothing is up and running. And if we do ls-a, oh, interesting. So the Alpine container ran and exited instantaneously. Why is that? So the command that it ran was bin-sh, but it didn't actually stay open. That's because when we're using commands that require a pseudo terminal, a terminal interface, we have to provide a couple of additional option flags to Docker container run. And in fact, you can look these up with Docker container run help. Nope, just kidding. -- help. In our case, we're going to be using two flags. The -i or interactive flag, and that keeps the standard input open. And we're going to allocate a sudo tty. In case you're wondering what a sudo tty is short for teletype, and what we're working with right now is in fact one of them. A pseudo teletype interface is what our command line is. So if we run Docker container run -i-t, you can also chain those -it, Alpine, something very different has occurred. Now we have a brand new prompt. And you're root inside of a Docker container right now. You are currently inside of it. Now, unfortunately, the second that I exit this thing, the container exits as well. We're starting to build up a bunch of stopped containers that don't help us out that much. If you want to, you can do Docker container rm and remove either by ID like this or by name, Hungry Moser, Bold Hopper, Jovial Gould, any of the containers that you want to remove. Or you can run Docker container prune, which will remove all stopped containers. You can see this ID matches this right here, this one here, and this one here. And if we run Docker container -a, there's nothing left. So what if we want one of those containers to remain open, even if we're not ready to work with it? So let's say I wanted to have it open, but I want it to run in the background. Another flag that we can run with it is in detached mode. So if I do dit or -d-i-t, it runs in detached mode. It gives us an ID. Check that out. So now our Alpine Linux container is open and running. So how do we, if we want to deal with it, how do we access it? Well, we said that we ran this in detached mode. There is, in fact, a Docker container attach. What attach will do is attach to the running command inside the container. In this case, it's bin-sh, so it actually works well for us. But this isn't always the best way to do this, and I'll show you what else we can do in just a second. So Docker container attached, then we have to give it either a container name or a container ID. I'll use the ID this time. And check it out. We've now attached to the running process. Here's the problem. If I exit this, guess what? I just exited the container because I exited the running shell process, right? So that's not the best. What else can we do? Let's fire up that Alpine again. So we'll container run dit Alpine. Okay. So you can see that we have container ls. It's running. Awesome. Now, I want to be able to execute a shell in there, but I don't want the container to die after I'm finished with it. What's the easiest way to do that? Well, a few things we can do. First of all, what if I want to run a single command and just get the output? I can do that. We can do docker container exec. We'll give it the container ID, and we'll say the command is cat etc password. And we get the output of just that command on our terminal. But if we want to interact with it, we can do exec-it, just like we did before with container run. We want interactive and with a sudo tty. And then let's give it bin sh. Now I have a shell. I'm inside of the Docker containers file system. Right? Everything's owned by root. You can see that there's this .docker end file, which is the signature of being inside a Docker container. And when I exit, the container is still running because I exited the new process that I initiated in the container, not the entry process that the container is connected to. So what do we do with these? Well, these are just kind of base containers. They're really not meant to be used directly, unless you, for whatever reason, wanted an isolated environment. But what they are designed to do is provide you a place to put your application code. And so, if we had something that we wanted to run inside of the Docker container, then we can put it in one of these things and execute it there, isolated from our host system. Let's try an example of that. Let's go ahead and make a new file. Let's make a script, actually. So we're going to just make a quick script here, a bash script. Or a shell script, I should say. Okay? Call it test.sh. We'll do bin sh as our interpreter. And we'll just say let's do bash. Okay, let's chmod.x test.sh. What did I do wrong? I forgot echo, didn't I? Yeah, I did. Let's try that again. There we go. Very, very simple. Very simple script. Now, we're going to add that file to our Alpine container. And we're going to do it by mounting a volume inside of the container. So we're going to do Docker container run again. This time with -v. This is a little bit interesting. To make this work, you have to use absolute paths. So we're going to use some bash auto completion or shell completion here to run the command pwd to print the working directory. And then that's going to be mounted after a colon to /mnt/test. Okay? And we're going to detach interact like so. And then we will run Alpine. Yeah, that's good. Okay. Now, let's run Docker container ls. Notice we have two different Alpine containers running right now. I'm going to kill this older one. Docker container stop to stop running containers. And then we're going to run, or sorry, exec it bin bash. Do we have bash in Alpine? No, we don't. So that's going to be a problem. But watch this. So we're going to run bin sh actually. Okay, and then let's ls/mnt. And then notice that I have this test in mnt. If I cd mnt test, there's this test.sh. Now, if I run it in here, it really doesn't work because I don't have a thing going on. So to fix that, I can do a couple of things, but I'm going to exit out of this command. And I can try dash as Nubin suggests. Yeah, that's not a thing. And now our script works. If we just do bin sh. So I kind of did that on purpose just to demonstrate that Alpine is so lightweight it doesn't even have bash on it. You can install other stuff, but by default it doesn't have it. Notice that it says I am root here. So the same thing gives us different output depending on whether or not we're running it from inside the container. The other thing is, notice that I didn't have to stop the container and rerun it after I made the change to the code. I just re-entered the container and ran the code from within the container. So that is both good news and super bad news. Let me explain. All of this seems like fun and games, right? But what we have done just now is demonstrate the easiest privilege escalation possibility with Docker. So be aware of security. Where do we need to be? Just a guy asks, where do we need to be in order to run the command that lists the running Docker containers? Anywhere on the system. You don't have to be in a special folder. Let's see why this mounting of volumes can be so scary. Let's do Docker container ls. Okay, we'll stop this running container. Stopping always takes a second. Okay, let's do a new one. Docker container run -v Watch this. Root. We'll mount that to /mnt host -dit, and then we'll do alpine. What I am about to do is mount the root of my host file system inside the Docker container. Think critically about this. What user does the container run as? So far, what user does it run as? It runs as root. So if I mount my host file system inside the container and now I'm root, I have essentially just rooted my host box. So this is the simplest privilege escalation mechanism with Docker, and it doesn't just work with Docker, it works with other container runtimes as well. You have to be aware of this. It's one of the reasons why you don't let this happen. There are certain policies in other tools like Kubernetes to prevent this very thing from happening, but let's see this happen. So we'll run this, and one more thing, we'll give it a name, actually. We'll give this one a name. Name Prevesk. Okay, now if I do Docker container ls, I've got Prevesk. Now let's do Docker container exec -it Prevesk bin sh. Okay, let's cd mnt host. Hey, look, it's a whole file system. If I look at home, let's cd into home and seclab, and notice that I have full permissions on this thing. All right, so let's echo I'm from Docker to hello.txt. Okay, let's exit out of this shell. Hey, look, a hello.txt. And notice that it was made with root permissions. Why is that true? Why is it true that root in the container is root on the file system? Because in Linux, users are based on user ID, and what user ID is root? Zero. The same as on your host system. So, two things went super wrong here, right? If we were doing this in production. One, we were running Docker without any guardrails. And two, we allowed this user to run Docker commands without sudo. This is like one of the first things that you do. If I find on a box, if I find that your user is part of this group, actually LXD is not great either, but if I find that you're a member of the Docker group, you're mine. I'm gonna root your box because that allows me to run those commands without sudo. So it's great for demonstrations like this, but never, ever, ever, ever do it in production. You need to have a barrier between users and the Docker container runtime. It is important to know about mounting volumes like we just did. That part is important. You'll need to do that very frequently. Imagine if you have like an application with specific dependencies of specific versions inside of a Docker image, and you need to run it, but you need to run it and get the output, right? I do this with Bloodhound all the time, actually. I run the Bloodhound Python thing inside of a Docker container, but I get the output into my host file system. I'm mounting a folder inside of that container so I can get that output back. So it's not that you can mount volumes, it's that you can mount all of the volumes and you're running as root, okay? How do you separate it? That is a great question. For that, we're going to go to one other cool thing, which is Nginx. All right. So Nginx is a web server. right? It hosts HTTP file or HTML files and other files, and it runs an HTTP web server. It's very cool. I love Nginx a lot. That's why I had you pull the Nginx image. Also, to show you this, we're going to do Docker container run -p, and also, I think, detached, right? -p. No, I don't think we need detached. Just -p. We'll do 8. Yeah, we'll do 80 to 80. Nginx. I should have done it that detached, but actually that's fine. Okay, so now I have a web server running on my Docker manager. And what I did, I'm sorry, I went too fast. -p publishes ports. This is port forwarding. What I've done here with this command is I've taken port 80 on my host and forwarded it to the container's port 80. And so, because I have this host saved, if I go now to HTTP Docker manager, thank you, Vivaldi, I know, I get the Nginx welcome page. All right, let's kill that. Alpine is still up. We're going to stop. Let's do Docker container stop privesc. Notice that I can tab autocomplete the names. All right, let's rerun Nginx. Let's run it detached so that I get my terminal back. And I'm also going to run it with yet another option we haven't seen before, which is -rm. What this will do is it will automatically remove the container when it's stopped, so I don't have to manually clean it up. Self-cleaning Docker container leaves only the fresh scent of pine. So we're going to rerun this thing. It's up. We still have access to it. Let's make some changes. So we're going to do Docker container exec -it Nginx, which does have bash. Hold on. That was goofy. Let's just take a part of this ID here and use it. There we go. Notice that this gives me the ID hostname because bash is better about that because that's the hostname. The hostname is the Docker ID. Okay, let's cd to var. No, my bad. User share Nginx HTML. Okay. Vim index.html, vi index.html. Come on. Apt install Vim. Apt update. Because it's based on Debian. So I'm inside the Nginx container right now running apt update. Apt install Vim. This is stupid. Don't ever do this in real life. There's no reason to do this. Okay. We'll vim index.html. And then we'll go ahead and delete this. Say, I got changed. Oh, I changed the title. I was like, where is it? Let's change the... You know what? No, I'm going to pull a John Hammond. There you go. There you go. So we can edit the files directly inside the container. Don't do that. The reason I wanted to tell you two things, though. Or I wanted to demonstrate two things with the Nginx container. So we exited that. We'll do Docker container stop that ID, which removes it. Docker container ls. Ain't nothing running. Okay. Now let's say, what's another reasonable way to do that? Let's make a new index.html right here. Right? And we'll just do, I'm bad HTML, but it doesn't matter. Okay. Now we're going to run Nginx again. But we're going to mount the volume here. We're going to do pwd. And we're going to mount... Oops, that's wrong. There we go. We're going to mount that to user share Nginx HTML, just like we saw the directory was inside there. Okay. Nginx. And now... Oh, hold on a second. We have a slight problem with permissions, I think. Inner exec. LSAL user share Nginx HTML. Yeah. So see how I don't have Nginx is struggling with this. So we'll do stop. We'll remove this container for a moment. We can fix the permissions inside there, but I'm trying to demonstrate two things. First, that you can mount HTML files inside of Nginx, and that's one way to manage your web root without having to worry about it. But that can be a little bit dangerous depending on how you do it. And there's another problem, which is that I don't want Nginx running as root, right? I don't want that to be true. So how can I fix that problem? I'm going to run Nginx one more time. But this time, I'm going to give it one other command, which is user. And we'll call it Nginx, because the Nginx container does have a built-in Nginx user. Now, if I take this ID and I do docker container exec-it here, bin bash, what? What did I do wrong? Dash U. Dash IT is missing. Nginx should not require IT. Wildegar. Yeah, it doesn't require dash IT. to run. Interesting. So we have this one running as root. Run -u nginx. Oh, we'll call it port 8080 for the second one. That's so crazy. That one just doesn't come up at all. Oh, hold on a second. I'm sorry. I'm going crazy here. One moment. Yeah, see? No matching entries and password file. I thought for a second that I was losing my mind. And I am a little. Yeah, that doesn't make a difference. Okay, so this is actually a teachable moment. Something's going wrong, and I'm not quite sure what it is. So if we do Docker container ls-a, well, these things just didn't get made at all. So interesting. Container logs. Yeah, there is no... That's crazy. Interesting. So what's supposed to be happening is that you can run Nginx with a different user, right? You can run these machines with different users as long as they're defined. So if we look at our running Docker container, there's an Nginx user. Oh, user 101. Let's try it one more time. I got the user ID wrong. Although it did have a user 100, but it was non-existent. So there's this Nginx user inside of the Nginx container, right? It's designed to have this other user. So what I want to try to do is run it as that user instead of as root. But for whatever reason, it is not playing ball. And I believe that's because I need to have a matching one in my Etsy password is the issue. So there are other ways we can run Docker rootless that's a little bit more advanced. So I think I want to pause on this moment to say, there are ways of securing Docker, and we will cover those in, I think, maybe a second session. Because there are going to be a few things that I want to cover that we won't necessarily have time for today, and that's okay. So we'll talk more about how to secure Docker later. Points I want to clarify, though. 1, we can mount volumes inside of Docker containers, and that makes it easier to have long-term storage. 2, Docker containers are meant to be ephemeral. They're meant to be blown away, which means you don't want to store anything precious inside of a Docker container. Your application code should come from someplace else, like a Git repository. It runs inside of a container, but it comes from someplace else. And long-term storage, like database stuff, is going to be stored outside of a container too. And you might be thinking, well, wait a second, Taggart, I know for sure that there are Docker containers for MySQL or other databases. Yes, that's true. That is for the database application itself, but where it stores its data optimally should be outside the container, someplace that is backed up, versioned, all of those things separately from the container that actually manages the database operations. That's what we're containerizing, not the storage. We're containerizing the running database software, the DBMS, if you will. So, okay, let's talk about making images then. how do we do this? There are two ways. Could I please habilitate the closed caption? I don't have that plugin. I'm really sorry about that. I don't think that's an automatic Twitch thing, but it will be closed captioned on YouTube for sure. I will look into getting that plugin. I have not disabled it. But I guess I have to set it up. I will make sure to do that. I'm sorry about that. Okay. Where are we going? We're going to make our first Docker image. The first way we're going to do it is the cheat way. This is something that most people miss when they're learning Docker, but it's actually kind of cool. Okay. So we have these Docker images so far. And while we can and should, in fact, make Docker images from what's called a Dockerfile, which is a set of instructions for how to build, it's like a recipe, a Docker image. The other way to do it is to actually take a Docker container and make a new image from it. As I said before, Docker containers, Docker images are just layers of changes off of a base. And so if we have a running container that is another layer of changes, we can basically squash it down and make a new image from that. So what do we have running? We have this Nginx running, right? Let's go ahead and access it. Docker container exec-it elegant feistal. I'm using the name instead. We'll do bin bash. Okay. And let us, we don't have nano, right? No. So we're going to do apt update and apt install -y vim. Again, this is why this is a bad idea. You don't have to add these dependencies to your container, so you shouldn't have to run text editors inside your container. But I'm showing you this just to demonstrate that it's one possible and two ways to make Docker images. So we're going to cd user share nginx html, right? We'll vim index.html, and we'll change the h1 to say custom image. Okay. Now that that's done, we exit out. If we do docker container help, you'll see that one of the commands we have is commit. And that creates a new image from a container's changes. Docker container commit. What does this do? We'll add an author. And then we are going to give it the Docker container ID. And you can see I now have a new container that doesn't have a repository and doesn't have a tag, but it does have a new image ID. Let's do Docker container stop elegant feistal. We'll stop that running container. And now we're going to run same thing, port 8080. that image ID. I didn't detach it. Let's see what happens now. There's my custom image. So I was able to build a new custom image just by making changes to a running container. And it contained all of these stuff that the previous image had, as well as my changes. But that's a really bad way to do it. You can do it that way, but it's a really bad way to do it. One, because it's not reproducible. And two, look at all of the extra stuff we had to add to the image to make that work. It's 54 megs larger. So that's not the best way to do that. Docker image rm. Let's remove that image. Oh, sorry. Docker container prune first. If you try to remove an image that even stopped containers are based on, you will not be able to do so. There we go. Now, how do we make a real reproducible Docker image? Easy. By making a Dockerfile. It's always nice to have the Dockerfile reference open when you're doing this. Dockerfiles have a specific syntax that we use to set up the instructions to build new Docker images. And if you want to learn about what your base images are doing, we'll talk about how to do that. But let's start by creating a new Dockerfile here. And I'm going to use Vim, of course. We'll call it Dockerfile. The first thing that I usually put in there is the from. It's really what you should have the first thing be. That's the Docker image you're basing it on. There's nothing new invented under the sun. That's definitely true of Docker images. So we're going to from nginx latest. Okay. The next thing we're going to do is we're going to copy, in my case, I think this works, index.html, and we're going to copy it to user share nginx HTML index.html. Okay. What the copy command does, as you might imagine, is move from a source to a destination. Each source may contain wildcards, and matching will be done using the file path.match. Oh, we can actually do relative here and then do absolute. So we can do copy index.html because it's in the same context. We don't need to do that. Great. So let's try just that much and see what happens. How does this work then? This is a very, very simple Docker file. We're going to do Docker image build. We have to give it a tag, or we should give it a tag. We're going to call this custom nginx. And that's the name of it. And if we want to give it a specific tag, we'll call it latest. Otherwise, by default, it'll be latest. Okay. And we can say build it in this context right here, this folder. That's what the dot is for. Now, by default, Docker image build is going to look for something called a Docker file. If you had a different Docker file, you would give it the name of that file with -f and then the name of the Docker file. By default, this will build. A bunch of things are happening here. we're getting nginx.latest, which we already have. Then we're copying index.html. And then we're exporting the layers, and we have a new image written. Now we have Docker image ls. Hey, check it out. We have a custom nginx. Notice that it's the exact same size to that accuracy or that precision as the nginx. Now let's try running it. Let's see what happens. Docker container run rm dp80. By the way, if you just do port to port, same port, you can just do a single number, so p80, and then we'll do custom nginx. Okay. Oh, I guess I'm lying about that. That port syntax. I guess that's not true anymore. There we go. Notice that when it copied over this time, we no longer had that permissions problem. So we've been able to make a new Docker image that has the code that we want inside of it, and then it'll run and have everything working with the permissions that we expect. That is a very, very simple Docker image build, but that's the basic idea. I'm going to pause right now to see if there are any questions or anything that we need to go over again for folks who may have jumped in early or jumped in late. No questions. Silent group. There's a bunch of you here today. Nobody has any questions. Okay, well, what we're doing is we're doing a full review of Introduction to Docker. So this video, which is going to be saved on YouTube in perpetuity, and it'll be available in 24 hours, is everything that you need to get started with Docker. Mitch, good to see you. Okay. Then let's try a little bit more with the Dockerfile. There's very little that we need to do for nginx to get things working because nginx is already set up for port forwarding and things like that. But what we can do is add some secrets to it in a really bad way. Let me show you what I mean. Let's vim that Dockerfile again. Okay. And we're going to use the env command. The env command sets up environment variables. We can do multiple env invocations, and it's simply key equals value, just like you're doing it on the bash command line. So we call it secret equals container secret 1, 2, 3. This establishes an environment variable inside of the container. So we're going to run Docker image build again. Okay. Docker container ls. Got nothing. So we're going to run it again. Okay. And then I want to do two things with this actually, because we haven't played with this just yet. We haven't played with the inspect commands. Both images and containers can be inspected, and what you get back is quite a bit. So if we do Docker image ls, of course, we see all of these. Now if we do Docker image inspect, and we'll do the image name, buckle up. Here comes a bunch of JSON. Now, this is a little interesting. Notice that it's all inside of it's a singleton array, and then we have this object that has an ID, all of this stuff. And notice that we even have config, including, the environment variables that we set up. So be careful. Do not put actual secrets in environment variables like this, because anybody who pulls the image is going to be able to see it. There's quite a lot of information to see about how the image is configured here. Now, you might be wondering if there's any useful way to filter this information. Kind of. There is a -F option for inspect that gives you a format string. Except, if you want to see how it actually works, the Docker formatting sucks. It's just awful. I don't know who designed... This is all from Go formatting. This is Go's fault. I don't know who designed it. I can't stand it. And so, if you are interested in using the data from inspect pretty often, I strongly recommend using JQ. It's not perfect, and it does take a little getting used to. But let's see, we've got ID. And what do we have? What is this inside? Config. Yeah, so if we just want the config, we can do custom nginx, JQ, .config, and we get just the config information. And since I can use JSON, I can use JQ to parse JSON from multiple different things, not just Docker inspect output, this is, I think, the better tool to focus on. And then, of course, I can nest that further if I just want config.env. Right, I can go down a little bit more with that. JQ is not, I'm not gonna say it's easy, but it has an internal logic that you can get to. So I strongly recommend using JQ to do your inspections. But again, the bigger point, rather than tooling here, is do not put real secrets inside of your environment variables, because they're going to be available to anybody who pulls your image, not just anybody who runs the container. But of course, they're also in the container. So we have a running container. Let's run some code on it. Youthful Archimedes. Eureka. Okay, so we're going to Docker container exec-it youthful Archimedes bin bash env. There is that environment variable that we defined in the Docker file. It's been loaded into the running container. Now, that seems like a useful thing if you've got API keys or whatever, but there are better ways to handle these, and we'll talk about those. I think maybe we'll do them today, but I think we'll probably do them in part 2. Can we use these custom nginx images created on Ubuntu on Windows? Okay. Docker is Docker is Docker is Docker. You can use the images anywhere that you can run Docker. That's the whole point. It is kind of a pain in the butt to run Docker on Windows, but you can do it. The Docker desktop is not my favorite thing in the universe. And I strongly recommend, if you're going to use Docker on Windows, do it in Windows Subsystem for Linux. But yeah, you can. Okay. So that's environment variables. Other cool stuff you can do with Dockerfiles. Let's just take a look at the reference real quick. A real fun one is add. Where are you at? Yeah, this is dope. You can actually use add with a Git repository. And so if you use... Yeah, if you add with a Git repository, you can just pull code directly during the Docker build process rather than cloning it first, if you're interested in doing that. So I could like load code in from someplace else. Now, that is possible, and I think it's neat. But the truth is that most of the time, the way that I do this is that I include the Docker file in a Git repo. So there's no point in reversing that order. But so in that case, what I can do is from a Docker repo, from a Git repo, I can copy my whole current directory inside to the Docker container, and then I can do whatever build processes I want to do. And why that's cool, right, is that then I don't have to worry about dependencies outside of the container. So Python's a great example for this. What if I need specific Python versions or versions of packages? Yes, I can use Poetry. Yes, I could use Venv. Yes, I could use pipex. But all of those actually depend on specific Python versions. What if I needed Python 3.7 for something? What if I needed Python 2? Oh my God. Well, rather than mess with my host system, I can run all of that inside of a Docker container. And not worry about messing with my host system. That is the whole point. It's VRL says the only difference with Docker is the runtime engine from Windows and Linux. I've had some issues with the Docker engine on Windows. So that's what I'm saying. Docker on Windows is kind of a weird shim, and I don't recommend using it unless you absolutely have to. Okay. Now, as you start building more Docker files, you may start being a little bit more interesting with it. So let's actually make one that isn't from Nginx. Let's do Dockerfile MyScript. Okay, so this one we're going to make from... You know what? Hold on a second. Let me do this a different way. Okay. Beautiful. So I like to separate things with folders. So I'm in a folder called MyScript, and I've moved the test shell thing that we did before inside there. Now, let's make a new Docker file inside this folder. Let's do Alpine this time. Now, Alpine has a problem because its entry point, the thing that the container runs as soon as it kicks off, is bin.sh, which is cool, but I actually want it to be different. So the first thing I'm going to do is copy test.sh to test.sh. Now I'm copying it to the root of the file system, which is okay for this purpose. You may want to consider doing something like, I think there's an mkdir command. If not, we can certainly run and do that. There's a run. Okay, so right. So if you wanted to make a new file or a new folder, we could do run mkdir this, and then that just creates a new folder. But we're copying this to the root of the file system because it doesn't super matter at the moment. And then we're going to do the entry point. And the entry point is the command that is run when the container executes. So we're going to make it test.sh. Entry point has several different options, or different ways of writing the command. An entry point allows you to configure a container. So this is useful when you want kind of a one-off script to fire. You want, like the hello world, right? It ran and then it exited. That's what entry point is for. Okay, so let's try just this much. I'm going to do docker image build -t my script. That's how we name the image. We'll do it here. Again, it has its own Docker file. Okay, do docker image ls. Now we'll do docker container run my script. It runs and exits. So it ran from inside the container and exited. So we've containerized our code. It's very, very small, but that's the basic idea. Okay. We're starting to get to the point where we're hopefully getting comfortable with the idea of bringing containers up, bringing containers down. Applications are almost never made of one container. As a matter of fact, they shouldn't be. One of the things that containers allows us to do is separate the concerns of an application. So imagine a standard PHP-based web application like WordPress. WordPress, generally speaking, has three components. We've got a web server like Nginx or Apache that is providing content and also providing the PHP engine. We have the WordPress code itself, and that thing has a certain version, right, and its own customizations that we make to it, plugins that we add, the name of the site. And of course, we have the database for the application where the posts are stored, the users are stored, any of the configuration data is stored. So generally speaking, a PHP application like WordPress or Joomla or Drupal or Moodle, I'm just going through a list of PHP applications I've deployed in my life now. Too many of them. They're all going to have that basic structure. Well, it turns out that you can create a Docker application and separate those containers. To do that easily, there is a tool called Docker Compose. Docker Compose allows you to define a Docker solution or application in a single file that is formatted in YAML, and then spin it up all at once with Docker Compose up. So let's do a quick demo of these things first, and I'll kind of show you from there how this goes. To begin, I want to show you a full working one, okay? A full working one. So let's see, Docker container ls Docker container stop u. Okay. Now if you forgive the log rolling a little bit, I have another repo that I use for this pretty frequently, which is from the PWST course. Which is the Practical Web App Security and Testing course. All of the labs in the course are based around Docker because it's really easy to spin things up and down. So in particular, if we go into CD resources, I think it's 3.4, yeah, CD 3.4, the WordPress directory has a WordPress Docker file, and a Docker Compose. So there's a lot going into this particular Docker Compose, but it's, I think, a really good demonstration of how Docker Compose files work and why we use them. Okay, so this is YAML. If you've never seen yet another markup language, or YAML, this is what it looks like. It is meant to be, think of it as a cleaner JSON. It is white space sensitive, so Python fans rejoice and everybody else lose their minds. I don't particularly like YAML, in part because it's so finicky. It's nice to read, it's hard to write, is basically my take on YAML. We have the version of the Docker file, or sorry, the Docker Compose file spec up at the top. And then we've defined these two top level things, services and volumes. Hang off on volumes for now. We'll talk about those shortly. But services are kind of interesting. Services are, one, named, in this case, DB in WordPress. But they are also, when we start getting into much later parts of this, able to be made of more than one container at a time. So a service, in our case, for simple Docker Compose is just a shell around a container. But later, a service may refer to multiple replicas of a container. That's where we get into scaling, right? If we want to have multiple instances of a database server or a web server running, right? Maybe behind a load balancer or something. Services wrap that. Okay, but we name our service, in this case, for the image here, we're going to pull from MySQL. We're using the volume to store the data. Remember, I said that your data should be outside of your container. This is how we do it. Then we set up some environment variables, nothing particularly special. And this is, in fact, not like the best way to do this, but for a simple demonstration like this, it's fine, right? Where we're creating what MySQL needs to spin up. Then we set up the WordPress container. It depends on the database service being up. This depends on means bring this up first and then bring this up. If you try to bring up WordPress before the database server is up, it'll fail. Now, notice also that we have an image just like we have up here, but then we have a build option, and this is kind of cool. Docker Compose files also let us build new images dynamically if we have a Docker file available to us, which we do in this case. Let me look at the Docker file. It's very, very simple. I basically just took WordPress and then added a MySQL client for testing reasons. But we have this build in here that will build this image for us, and so we'll be using the PWST WordPress image. We're also mounting a volume for WordPress data, so this is stored outside of the containers. The reason we do that is, let's say, for whatever reason, we mess up something, or we want to bring down the WordPress application. We're going to bring it back up, but our code remains saved outside in this directory. So not the data necessarily, but any of the configurations, the PHP files that we use, those will be consistent. Now, if you want to fully blow it away, you can, but we're trying to save those outside so that we can keep our code independent. Keep in mind also that the WordPress image in this case actually contains an Apache web server. So if I wanted to split it up even further, I would have a separate Apache web server or Nginx web server in front of the WordPress application. But for now, this works fine. Notice also that we're forwarding port 8000 to port 80. So this is the port that will be available to us. And this is what we can access the WordPress instance on. And we're setting up some WordPress environment variables as well. And these kind of have to match this. That's the idea. So this is all set up to work with this. Okay. So that's how Docker Compose works in terms of its specification. Now let's bring up an application with Docker Compose. Docker Compose. Notice that it is a subcommand of Docker. It used to be the case that Docker Compose was a DLC thing that you would do, and it would be docker-compose. That is no longer the case. If you've installed Docker the way that we've demonstrated today, Docker Compose is what you want. And then up to bring up an application, -d for detached. By default, it will look for a file called docker-compose.yaml, which in fact we have, right? So we're going to do docker compose up -d. It's pulling the WordPress image. It's pulling the MySQL image. And then it'll build our custom image. All of that is happening for us. Notice that it looks a little bit different than how we did the image pulls when we just did raw Docker image pull. But it still gives us a sense of what's happening. Here comes the build. This is the build process that we specified in the compose file. Every single one of these SHA-256s that you're seeing here is the result of another instruction in the Docker file to build the image. Every one of those introduces a new change, which then creates a new hash for the layer of the image. That's what all of these hashes refer to. Then we run our own instructions from our own Docker file. So all of this was from the base, and now we do our own. So that's up. We now have a new image. Okay. Let's take a look at what we have here. Docker image ls. Yeah, let's do that. Check it out. PWSC WordPress got built. It's huge, by the way. Notice that it's 673 megs. And MySQL ain't no slouch either at 455. Be aware of that your images and containers can start taking up more space than you might expect. Okay. Docker. Yeah, right. Nope, not yet. We're not there yet. But if we do Docker container ls, I now have two things up. Docker Compose brought up two things for me at once. It brought up the WordPress and the MySQL. Now, if I go visit port 8000, I am presented with a WordPress install ready to go. Notice that it's not asking me for database stuff because that's already been set up for me, right? I can just set this up. Let's roll cybernetics. Password. Is that not the easiest WordPress setup you've ever seen in your life? And then we're in. So with no trouble at all, I was able to just set up WordPress by using this Docker Compose file. Now, that's part one of why Docker Compose is awesome, because it makes this kind of setup way easier, right? I didn't have to follow long instructions from a DigitalOcean tutorial or whatever. I didn't have to enter a bunch of special commands to set up MySQL. There are definitely things that I should be doing to make this more secure. Absolutely true. But this is a starting point, and it's a much lower barrier to entry than some of those other methods of doing this. That's one reason why Docker Compose is so cool. Here's another reason. Let's say that there's an upgrade to PHP. I can then update the images, the individual images that this is based on, right, and redeploy the images. But because I saved my code and my data in separate volumes, I can blow away the running containers, bring them back up based on new versions of the image that contain the Apache or WordPress versions, whatever I want, or MySQL even. Bring those back up, and my data has been preserved, but the application code has been updated. Now, think about doing that for your own products. Every time there's a new version push, how do I deploy it? Well, I can deploy my code containerized, and the data that my application relies on can be persistent, but the versioning of my code can be constantly updated. Now we're starting to get into what's known as continuous integration and continuous deployment. That is why containerization is so exciting, or one reason. It enables this quick redeployment of new versions of code. And then with tools like Kubernetes to orchestrate some of that, if there are failures in the redeployment, you can roll back to known good states. That's cool too. We're not going to get into Kubernetes during these clinics. Now, to bring it down, we just do Docker Compose down. Now, Docker Compose down has a couple of extra options as well, right? So if I want to blow away the volumes, which in this case I do, I'll do Docker Compose down -v, which will also blow away those external volumes. But you know what? Before I do that, let's talk about volumes. Docker volume ls. Check it out. I have 2 volumes that have been created here. What in the world are volumes? We've said that that is where persistent data is stored for Docker outside of containers. But where are they? That's a fair question. Let's inspect one. Docker, that's not how we spell that. Docker volume inspect. Wow. Inspect data. This is where it is. So if we actually ls that location, sorry. Hey, check it out. All of my stuff is getting saved in this special directory. Notice that it's owned by LXD, by the way, and then Docker to create the volume. It's just a directory on my host system. Now, that is also because the driver for the volume is local. There are other kinds of volume drivers, and in fact, it's even possible, this is key, to create network-based storage so that multiple containers across multiple Docker hosts can access the same volumes. That's a little bit next level. We're not going to get to that today, certainly. But that is how you would handle distributed usage of data. So for example, a single database, right, storage location with multiple database servers, you would have to handle some with sharding and things like that. You would have the ability to have a single volume or multiple volumes distributed, but you would use a different kind of driver rather than local to make the volume. Its VRL asks, what does Watchtower play a role in this? If any, what role does it play? Watchtower is a Docker service. It's a third-party thing. Somebody just made it. And what it does is it watches for new versions of your images that you've published or that you're using, actually. And on a specific cadence, will look for those new versions, pull them down, and redeploy any containers you have running with those new versions of the image. So it is pretty cool for that reason. If you want to automate the deployment of new versions of your code, you can use Watchtower to do exactly that. I think we'll save that for later as well. That's a pretty cool topic, but beyond what I want to get into today. Let's bring down the WordPress site. So Docker Compose down -v, and that will knock off the running containers. And because we added the -v flag, it will also knock off the volumes. And one other thing. Do you see? There was a network that was created as well. And this is really interesting. The network was something that Docker Compose created for us. And it allowed something pretty special to happen. It allowed the WordPress and the MySQL containers to connect to each other without using the host's own network and not using my network. Docker has its own networking layer that allows you to create ad hoc networks. Why is that cool? For that, we go to Excalibur. Seriously? I need... Yeah, okay. So, let's make ourselves a Docker host. Docker host. Hooray! Now, let's make ourselves some containers. Let's call this Nginx. And let's call this... let's go with Redis. No, let's go with MySQL. Okay, so Nginx, MySQL, and we'll do... Let's do one more, actually. So, everybody's favorite technology. Node. Okay, so my Docker host has 3 running containers. They are meant to be a 3-part application. The application code itself, the business logic and all of that, is a Node.js application. That's where everything's going to be running. It could be Express.js or whatever. It is going to connect to MySQL to store and load data, and all of that is going to be served out a front end with Nginx that is also going to handle the SSL certificates and all of that cool stuff. Okay. If that is true, I've got 3 things that need to talk to each other, right? But how many of these things actually need to talk to the internet? What do we think, chat? How many of these things actually need to talk to the interwebs? Just Nginx. So, what if I had the ability to expose Nginx as with a port forward, right, as we've seen, but create a second network that was just for our friends? Keeping everybody safe and sound. That is what Docker networking allows us to do. So, and this happens implicitly when we use Docker Compose, where we are creating a new network that these 3 things can connect over. And it does one other thing that's kind of cool. I don't know if you caught this. It was a little subtle. Look at the environment variable for our WordPress container for the DB host. It's called DB. Where is that defined? The only place it's defined is the name of the service. Docker will turn service names into routable host names inside of the network that it creates. Let's play with that a little bit, because I think this section is misunderstood by most folks who play with Docker, but it is so powerful. Let's bring up a couple of Alpine machines, and we're going to do this manually. I also want to show you in Docker container run that we can create networks and add them, or add network. We can create networks and we can add containers to them. So let's start with Docker network first. Connect a container to a network and then create. We'll do Docker network create first. So Docker network create, and then let's do -- help just to see all of the things that we can do with Docker network create. Okay. Driver to manage the network. The default is bridge. Let's see what Docker networks we have. Docker network ls. The bridge is our default. And that's fine. If we look at our Docker network options, you'll see that there are some other kinds of networks, which we will get to eventually. But the driver bridge is fine for now. Let's do Docker network create and attachable, so we can attach containers to it. Testnet. I now have a new network called testnet. If we do Docker network inspect, what do we get? It has its own subnet already. And we can see that it is different than the bridge subnet, right? The bridge subnet was 172.1.7. But the testnet is 172.1.9. And it has a gateway. Okay. Now, I wonder if it's possible to make your Docker network IP6 only. I don't know if it's able to do IP6 only, but I know you can enable IP6. We need to fix all that NAT nonsense. You can set an IP6 gateway, Vale, so that's definitely something to think about. Okay, let me get out of this PWST resources folder. We don't need to be there anymore. Let's do Docker container run name testnet1 rm d it alpine. And let's do testnet2. Docker container ls. Don't forget, we have Docker network connect. So we're going to do Docker network connect. And I think it goes network container. Yeah. Testnet testnet 1, testnet 2. Okay. Now you can see that my testnet container has 2 different containers inside of them. Notice that they're on the 172.19 subnet. Docker container exec-it testnet 1 bin sh. Good. Ping c4 testnet 2. Check this out. I was able to use the host name testnet 2 without having to specify an IP address, and check it out. It is coming back on the 172.19 subnet. It's using the network that I created specifically for these 2. That is how Docker networking works, and this is what makes it so cool. So all of that is happening under the hood when we use a Docker Compose file. You don't need to worry about that. But I wanted to show you the manual version of it so you understood what was happening when you actually created Docker networks. Hey, Volley, thank you so much for that sub. Appreciate that, friend. Okay. So obviously we can do Docker container stop testnet 1, knock these off. And testnet 2, it won't have let us destroy the volume until we either removed the container. Sorry. We wouldn't have been able to destroy the network until we removed the containers from the network, or we stopped the containers in general. Okay, and then we can do Docker network rm testnet, and that knocks that off. Okay, so last thing then is let's bring up our own quick composed file. Let's cd my script. Okay, and let's vim docker compose.yaml. Version is 3.9. And then services. We'll call one of them Nginx. Or sorry, services. Nginx. Let's call it web just to distinguish, right? Image. Nginx latest. And environment. Did I break Vim somehow? Interesting. What in the world? The manager changed its IP address. That's not at all helpful. But at least the worker came up. So the manager's now 118. Thanks so much, DHCP. I really need to fix that bug. And the worker's at what? 120? 117. Okay. No biggie. We just need to kill this pane. And SSH lab Docker manager. Whatever. Okay. What were we doing? We were vimming a Docker compose, but actually, right, services, image, volumes, environment. There we go. So they're individual objects, not lists. Wanted to confirm that. Okay, vim docker compose.yaml. Yeah, we're gonna recover it. Cool. Thanks, Vim. So the environment, we'll call it just secret 123. There's nothing special about this. I just want to demonstrate environment variables. Okay. Web, and then Alpine. Oh, sorry. One other thing I wanted to do. Ports. 80 to 80. And this is how we expose ports. And then Alpine. We'll do image Alpine latest. And let's see, do we need anything else? It's going to run detached anyway. TTY configures a service to run with a TTY, which is exactly what I want. Okay. And let's just try just that much. Now, Docker Compose has a couple of cool things that it can do. One of which is it can config service. It can tell me if I've got something wrong in my Docker Compose file. And in fact, I did. Services. Anyway, yeah. Sure. I gotta kill that swap file. Okay. Now if we run docker compose config, if it gives you the output, you're solid. By the way, notice that I didn't write a network section, but it made one for me. I do docker compose up -d. Let's do docker container ls. Hey, look. I have both an Alpine that's running and an Nginx that's running. Let's head into docker container exec it my script alpine 1 bin sh. Okay. And let's ping C4 web. Because again, I can use the service name. 172.20. Still not the same as the 172.17, which we saw Docker's default network was. These things are connecting over the ad hoc network that Docker created for our services. This network isolation is a really important component of how Docker does what it does, and notice that it did it by default. What that means is that when you use a Docker Compose file and you expose a single host with a port, it's only publishing that specific port on that specific container to the general web, to the general network. Yes, we can still access this thing, right? If I go to Docker Manager here, I still have access to the Nginx service, but I cannot go access anything else that was working on the network from here. So that network isolation is a really nice component of this. Okay. Docker Compose down. It knocks off the containers. I hope. There we go. And then it removes the network. Okay. Friends, I think that is a good stopping point for today, because what we're about to do next is going to require 2 VMs, and it's going to blow your mind. We are going to be able to deploy Docker containers and Docker services across hosts, but that takes enough time and enough configuration that it's going to take its own thing. So I think we'll reconvene with that next Wednesday. We'll finish up. We'll do Docker Clinic Part 2 on Wednesday. This session will be available as a recording on YouTube in 24 hours. And if you could, if you're not subscribed there, I would appreciate it. And if you liked what we're doing here, I'm trying something a little bit new with the streams where it's a little bit more didactic, a little bit less watch me get frustrated by hacking a box. So if you like what we're doing here, please provide feedback one way or another and tell folks about what we're doing. Don't forget that we have courses that are long form at the Taggart Institute that are free or pay what you wish. So if you're interested in checking out some of those, please go see taggartinstitute.org for those. All right, so that's going to do it for today. Oh, perfect. We have a lot of folks who are streaming. The hack list is always a great resource for InfoSec streamers. But for right now, I think we're going to give Cerberus a raid. She's probably doing some cool malware analysis, so definitely worth checking out. We'll raid her, and then I'll be back on Wednesday at 1700 PST or 0100 UTC. Until next time, friends, please be good to yourselves, be good to each other, and happy hacking. I'll see you next time.